Hi, I'm Tom Seppi, and just a little brief introduction about myself. I'm basically a multidisciplinary artist. I've worked in everything from theater to large-scale metal art sculptures to fine art bookmaking and letterpress printing, and basically just run the gamut of like different things. I also did a lot of performance art, and used to perform in a fire dance troupe where I was walking on stilts and breathing fire. So I've done a lot of different things in my life, and but tonight, if I can make this work. Tonight I'm going to be giving you a little, here we go, oh, everything's all over there. Hi. No, don't want to join your Wi-Fi network. Okay, come on. There we go. So I'm going to give you a little intro to Arduinos and microcontrollers. And so how many people here have ever programmed a microcontroller? Oh, that's pretty good. That's pretty good. That's more than I expected, actually. And how many people have specifically worked with the Arduino? Okay, good. So that's actually kind of the same number, actually. So if I was going to make an analogy about, the Arduino and the microcontroller, I would say that, the Arduino is like an all-access pass to this incredible party that we call the silicone world. It's like there's this thing going on, and we've all known about it for a while, but we don't have access to it. But the Arduino is kind of like this all-access pass to this party, right? So what is a microcontroller? This is a microcontroller. It's basically a chip, a silicone chip, but it's more than just a chip, because it's basically a miniature computer in and of itself, right? So what you're looking at is just like a little black box with a bunch of pins on it. And but what it is actually it has onboard RAM, it has a CPU, it has it's programmable, it has inputs and outputs, and it's just a little tiny chip that is basically actually a miniature computer. But to access it on your own, like, you'd have to be kind of an expert in electronics to know how to, okay, I got to hook up 5 volts there, and then ground here, and analog, and this and that, and you kind of have to know all these things and do it right. Otherwise, you'll fry the chip, which is only a $10 or $5 chip at the most. But then you're like back online ordering stuff, and so. What's so amazing about the Arduino is that the folks who in Italy that started this project, you can see the chip there down on the lower right. They took that chip and they stuck it in a board, and this board gives you access to the chip. It's basically plug and play. Didn't bring my laser pointer, but I'll just kind of point it out to you. The top left there is a USB port. So you can literally plug this thing into your laptop or your desktop computer and start programming it. There's a power port on the bottom, and there's a couple of capacitors there that filter electricity to the chip. And then there's headers on the top and the bottom there that basically give you, those headers just basically connect to those pins, essentially, shorthand here, but so that you can actually, oh my goodness, look at that. Oh, I love this. Right, okay, all right, here we go. So these are the headers down here. So we have analog pins, we have 3 volts, 5 volts, so these are the digital pins up here. So basically these pins connect to the pins on the chip. So this powers the chip, this gives you the ability to communicate with the chip, and then these give you the ability to go in and out with data. So not only can you control things, but the Arduino can also be controlled by other things. So it's about input and output. So okay, so I explained that. The amazing thing about this chip is that it's that the Arduino is that it's basically like it's kind of like it's just like I said, it's like it's giving you this all access pass to play in this realm, you know, that we've known about for decades now, but for most people it's something that's too esoteric, it's too difficult, you know, not just the electronics, which is what this solves, but then the programming as well. And so one of the cool things about the Arduino is that there's a community of people that have developed like a very simple programming language that gives you access to programming this chip without having to know what the language the chip wants to communicate in, which is like machine language, which you could never understand. It's like zeros and ones, right? So you can actually use shorthand essentially to program this chip. So I'm gonna show you a simple example of that. I knew you were going to say that. So this is the microcontroller that we're all raving about. It's like, oh, right. But right there's another microcontroller, and you can look how small it is. Look at all the pins on that. There's only what was it, 20 or something pins on this chip, but there's like a lot more on that one. We'll talk about that later. So this is a very simple project. You can see this is a very bad photo, but that's the USB port. There's an Arduino on the bottom of this. This is a piece of paper folded in the shape of a cube with a few LEDs in it. Okay. Here's the components. You can see the Arduino right there. There's the LEDs. They didn't even use one RGB LED. They used actually a green, a blue, and a red LED, and one cable and 3 resistors. Okay, and that's all it took to make this project. And literally, this is like a mood light. So this is like something that you can wire up with just very minimal components. Literally, it's plug and play because you don't need to solder. You can literally push this stuff right into the holes in the breadboard, and it's actually just 65 lines of code. Actually, if you took these lines in the comments out, it's only like 53 lines of code. So it's like very, very simple, like 53 lines of code, a few electronic components, and you can start building a light that's glowing and pulsing and doing different things, changing colors. So it's very, very, very accessible, and that's why it's so amazing. But beyond that, like it's kind of like Legos for electronics, because I mean it really is plug and play. Like you can stack. Look at this. This is Arduino on the bottom. And then this is called a shield. This is like probably a audio shield. There's the SD card in there, and then this is an Ethernet port. So they've stacked 2 shields on top of the Arduino. So you're literally just stacking electronics and building functionality, which is just like, I mean, you just pick these things up for like 10, 20, 30, 40 bucks, and next thing you know, you're just copy pasting code and moving forward. And now it's like you not only do you have access to this party that I was talking about, but you're actually creating the party. Like that's actually what's so exciting, is that you're the one in control of this situation. So now you're in there and creating things and looking at what other people have done and starting to build, you know, whatever it is that you want. So what I want to do is I want to showcase a few projects that other people have built that I think are really amazing. So here's one in particular. This is a 3-dimensional LED cube. And these are, you've heard of pixels, right? Well, these are voxels, right? So it's a 3D space of pixels. And the Arduino is what controls it. I have a little video that I'll show you. And it's a whole other way of thinking in a way when you start going into 3D, because you have to create these patterns, but somebody else has, and that's what's so beautiful about it, is that you can actually find this person. I got this from Instructables.com, and so you can actually follow this person's footsteps and build this exact same thing, or a smaller version, or a larger version, and do what you want to do with it. This next project is that's actually in the middle. This is actually an Arduino right here, but it's in the shape of a circle here. It's called the lily pad. And this woman, whose name escapes me, but she's actually a associate professor at MIT, and she developed the lily pad. And it's Leah Buckley. And she, so this is a hoodie that you can wear when you're riding your bicycle, and it has turn signals, right? So here's her Instructables.com. This is what you need to make the project: pair of scissors and some, like here's the Arduino, and you need this conductive thread, and here's the layout. So basically, here's the LilyPad Arduino, which is the same thing that we saw earlier, just in a different format. And these are actually conductive pads that you can solder wires to, and then those wires you can sew into your hoodie. And there's buttons on the sleeves, so that you can control it as you're riding your bicycle. This is one of my favorite projects. It's called the Clap-Off Bra. Speaking of clothing, sometimes you want to wear the clothing. Sometimes you want the clothing to come off. So this is actually a bra that when you clap, it like unhooks. Not safe for work. Okay, this is an audio project. It's a laser harp, and I don't think I have the means. Wait, maybe I can actually. Yes, I can actually play the audio on the next slide. So this is obviously a lot more advanced because you have a laser and other components to control it. But essentially, underneath all of this is an Arduino that's taking the commands, and what it is, it's a musical instrument. It's actually more of a lyre than a harp, but I don't know if it's playing or not. Oh, we tried. But this guy's basically playing a song right now through putting his hands over the laser beams, and there's actually a sensor on the floor that is reading the light from his hands and the intensity of it, and that controls the audio of the sound. So, and that's, again, all done with this simple little board. Oh, I think you turned it down there. Well, let's try real quick. Oh, there we go. He's got a drum track. Yeah, so there you go. A lot of people have been creating robots with the Arduino, that's one of the great things about it. Again, you have inputs and outputs, and this particular project is a remote-controlled lawnmower that somebody built, and they got a wheelbarrow around there, a little battery, and they're actually able to remote control it, through radio waves. This, however, is an autonomous robot, which people have been building. And this one has sensors in the front, and it's basically like a wall-avoiding robot. You turn it on, and the sensors tell it when there's a wall nearby, and it makes a turn. And so it'll just keep running around and avoiding things in its path. This is a little bit more advanced. This is actually a mini Segway. So it's a self-balancing two-wheeled robot built with an Arduino. You can actually see the Arduino board right there. And so, I mean, you've seen those people riding around those Segways. This is a little mini Segway Arduino. This next project, however, is something that it's really inspired me and moves me a lot. It's called the what's it called? iWire. Sorry, I'm blanking on the name of the project. iWriter. Thank you. I should have put it in the titles. But basically, what it is, it's there's a camera and these infrared LEDs, and it reads the movement of your eyes. And so this man right here is a graffiti artist that was paralyzed, completely paralyzed. He could pretty much only move his eyes. And so they built this device that is reading the movement of his eyes so that he can write graffiti. And they're working on another version of it that is for people who can move their heads or what have you. And here's the different glasses that they're playing with. And here it is hooked up to a paint gun. It's kind of fun. But yeah, here you can see essentially the rig, which is, there's basically like an Arduino in here, and then here's a camera, and it's completely open source. They have an incredible instructables about it, and you can go to their website and you can actually build this yourself. And that's the other thing that's so amazing about this thing that's come about, this Arduino, and the community of people that are supporting it and building these things and then sharing with each other, so that you can essentially, follow in their footsteps and go from where they've been. So this is an Arduino-based satellite, which is designed to launch in a rocket and go in orbit. Solar panels, minimal structure, cameras, transmit and radio control, and a flight control computer. Oh yeah, this is called ArduSat. Yeah. Yeah. But if you don't have access to rocket ships, you can build a weather balloon, right? So this is an Arduino-based weather balloon, and what it is, there's a Canon camera. Here's the Atmega 32 microcontroller, which is basically an Arduino. There's a GPS module. There's a cellular antenna. There's a 5-volt regulator for the power, and then here's a radio modem and an antenna for that. So it's basically a bunch of electronics that allows you to go up into the air and communicate with it, and it'll take pictures. Here's them about to launch it. So they put it in like a styrofoam cooler, because you get it high in space and things start to freeze. And then here's an actual shot taken from outer space with an Arduino, and a camera. So I've been getting into this stuff a little bit, but then a couple years ago I got hired by full-time by a company called Obscura Digital, which kind of took me to the next level, because all of a sudden, we're doing stuff that is like way beyond like little tiny microcontrollers. I'm working with really fat, amazing computers, and for instance, this is us projecting on the outside of the Sydney Opera House. And I can't even tell you the amount of computing and electricity that went into that project. But most recently, we did a project at the Exploratorium, and this is a behind-the-scenes shot. And what this is a scale model of the Exploratorium building at Pier 15, 17, 15. And I built this scale model and poured it with layers of colored wax, and we're melting it with heat guns. That's me. And then we're filming it at like 60 frames per second, and we took that film footage and projected it onto the actual building. So it's like psychedelic melting of actual wax, So that's just, so we do everything from like, full-on crazy digital video projection to stuff like this. And then most recently, as Donna mentioned, we have an installation up at the America's Cup Pavilion where we're doing these interactive kiosks. And in order to do these things, we had to kind of integrate, like real-world inputs with our computer systems. And it was like, well, how do we like get this like movement that people are doing into, like, we want people to be able to interact with what we built and then have that affect this projection system that we've created. So this was one of the projects that I just recently completed with an Arduino. And this is actually one of the steering wheels from one of the America's Cup yachts, which is like this total carbon fiber, super lightweight, crazy steering wheel. I couldn't believe when I picked it up how light it was. And what it is, it's connected to this pillow block bearing and a timing belt pulley. And the timing belt pulley is connected to this. This is an old hard drive, which I pulled the platters out and then used the hard drive signals to give me position data. So as you turn the wheel, it's connected to that little motor, and it's sending a signal back to an Arduino. Here's a little bit more of what's going on. So you can see this is the back of the pedestal, and here's where the steering wheel is connected. And there's a pulley that's connected between these two. This is the old hard drive motor, and then these three wires come down right here and connect to the Arduino with an Ethernet shield on it. So I'm sending data through an Ethernet cable from the Arduino, which is telling me where the wheel is, and sending that to a PC, which is then using that data to control a video projector and a bunch of information about the different people that are racing in the America's Cup. Of course, it didn't work the way I wanted to. So what I did was I took an optical mouse and I soldered wires directly to the chip inside the optical mouse and wired them up to the Arduino, and then I put the optical mouse right on the shaft of that thing that you saw earlier. So I bypassed this whole, I just like erased this whole thing basically, and I just put the optical mouse right on this shaft. So it's kind of like, you move the mouse around on the table. Instead, this thing's spinning and it's feeding data into the optical mouse, and that's actually turned out to be a much more reliable way to get data into a computer. So a little trial and error.
How long did it take you to figure that out?
Not very long, actually. It just took a lot longer to implement it because of how difficult it is to get into places because of security and access passes and things like that. But speaking of trial and error, this is also for the America's Cup. This was a project that they wanted to do that was like a water feature thing. So this is my first prototype, which is this is basically a water pump right here. And it's pumping water up through here into this chamber and then back into the pump, and it just kind of cycles around like that. This is a little bypass filter so I can try and control the flow. And the idea is to have like a little mock hydrofoil like you have on a boat. So the water's flowing, it pushes the hydrofoil up. Water's not flowing, the hydrofoil drops down. So this didn't work. So I built this one. The nickname we came for this project was the Hydro Donut, because it's basically like a circle of water. That one didn't work either. So then it was like, all right, we need to control the flow like a wind tunnel. And so I built this thing. This has nothing to do with Arduinos, but I just kind of had to show you the process of what goes into these projects, and this didn't work at all. It was terrible. That's that thing you just saw right there with this. It's just crazy. It's terrible. So then I went back to a plastic tub. This is just a plastic tub with basically little jet nozzles like you'd have in a hot tub, right? It's like you sit in the hot tub, like, oh yeah, that feels good. They've got some flow there. Well, this is basically what this is. It's a pump motor shooting water across. That worked. This is the actual kiosk getting built. So this got clad and painted and looked really nice. And there's just tape over the acrylic here, so I didn't want to scratch it. But there's a plunger right here that pushes this little hydrofoil up and down inside the water. And then there's a bunch of sensors that we integrated into this project that are integrated with an Arduino. So there's an Arduino that's controlling lighting. There's an Arduino that's controlling there's a pressure-sensitive mat that's in front of the kiosk. So you step up to it, you step on the mat. The Arduino senses that you're there, and it turns on the pump, it turns on the projection, and then there's another infrared LED and a infrared receiver and a resending LED that senses where the plunger is in the path, and that affects the animation that you're seeing. This is an art car that I built for the Burning Mans. I don't know who's been to the Burning Mans. Been to the Burning Mans? I heard last year was the best year, but so I'm not going to go this year. So this was actually, I did exactly what I would never tell anyone to do, which is I built an art car from scratch. And this is the frame. This is a motorcycle engine. This is it actually out in the desert. This is the ray gun Gothic rocket ship, which was out at the Barcadero for a while. I was part of that project. So it was kind of all inclusive. It was like, built this moon rover, we did the rocket ship and all this stuff. And I was like, well, I built this thing, and it was like, it kind of needs a little something. It needs a little extra pizzazz. I don't know. It's just like, I need something. So I was like, oh, so, I I built this little box, which I actually have here to show you. Basically what I did was I took an existing, this is like a, what is it, like a DirecTV box, you know, that, and I was like, okay, I can here's the Arduino. This is another shield that I was talking about before that plugs into the Arduino, and it's like an audio shield. So I can like save audio onto this card, and I can play it back through the Arduino. And so here are my buttons. Oh, you'll get to hear them in just a moment. So here it is. I started hacking. You know, hacking is one of my favorite things to do, right? I mean, it's not just because I like to break things. It's because like hacking is a way that you can take something and make it yours, you know, and that to me is what's so vital about, like, it's great to you know, look at all these projects and do these things, but until you break the seal on that one screw that's got that little sticker on it that says, you know, this will void the warranty. It's like you don't own it, you know. It's like it's not yours until you break that seal. And once you do, you claim responsibility for the thing that's in your hands. And so that's part of what's so powerful to me about hacking, you know, is that it's like you're basically claiming responsibility for your world and making it, you know, in a way that you see, that you want to see. So this is my first attempt at putting it all together, and I got the buttons installed in the box now. Oh yeah, I'll come back to this. So what I'll do is, that's pretty much the end of the slideshow, but here's the object. And so what it is basically this little box. And you can see all the buttons here. And I've programmed in different sounds, and as I change the switch, it changes between the different banks.
I'm sorry, Dave. I'm afraid I can't do that. I've just picked up a fault in the AE35 unit. 15 minutes to ignition.
So obviously this bank is all full of 2001 Space Odyssey sounds, you know. Like, and then as I switch the thing, I can...
Your choice is simple. Join us and live in peace, or pursue your present course and face obliteration. Something very important I forgot to tell you. Don't cross the street.
So this is like, it's just endless hours of fun, right? Right. Those are all from the video game. These are all 8-bit sounds that I found online. Who recognizes that sound? Defender. Defender.
There's something screwy around here.
One of my favorite games ever. This is when you put the quarters in the machine, you know. So this is basically... And then I also included in this thing a little thing I found at Radio Shack, which lets you say, "I can't believe it." So I can like actually on the fly record my own sounds, and it actually has. So I hacked the whole box, so there's actually an audio out, so I could actually plug this into a sound system. I could unplug it from the 110, and I can charge it on 12. I could like have it run off of 12 volts, so I can actually run it in my car if I wanted to, you know. So this is kind of a fun little project, and just to give you like the full Monty here, I'll just open it up, and you can see, you know, here it is. It's like barely held together. I dug it out of the vaults, you know, but here's the Arduino, the sound card. It's still working, and it's basically a little hack together electronics job, you know. And it's it took me. It was definitely one of the most advanced things that I'd done. So that was basically that was basically a super fun thing, and I continue to want to do more with Arduino. I continue to be inspired by people who are doing stuff with Arduinos, and yeah, and at this point, like I guess pretty much the end of my talk, and I'm open to questions. Oh yeah, the little kid. I just want to point out the little kid, because that's kind of what's going on here too. Is that kids of all ages are diving into this, and it's like, and that's it's like Douglas Rushkoff says, program or be programmed. Right, and that's the world we live in right now. It's like if you don't actually engage in this world, then you're just consuming what's being given to you, and the opportunity is there with this to actually program or create your world. And at this stage, as artists, as people, as creators, the Arduino gives us this access on this level that we haven't had before, and so that's kind of why it's so inspiring to me. Yes, in the back. Which? This? Absolutely not. But we could work something out on a side deal. Yeah. I'd be happy to commission one.
What does the team look like as far as like developers, designers, engineers?
For Obscura, we're a very small company actually. I mean, we kind of contract and shrink depending on people's moods, pretty much. But we're about 40 to 50 people working full time, and any one project might have 10 people working on it. So it's pretty small. Depending on what's happening. Sometimes things grow. Like a big project, we might have 20 people, 30 people working on it at once, but. It's pretty. That's why they love me, because I can do lots of different things, and so I'm like, oh, can we hire smart people? Yeah, totally. Yeah. No, it's actually. I mean, I kind of skipped over some of that because. Hey, we got a talk going on over here. I'm just saying. So it really is. So one of the cool things about this Arduino is that you can literally copy paste code in order to do what you want to do. There's libraries that, like for instance, like I was showing you this one which got that Ethernet shield on it. There's libraries that I download and load onto the Arduino that allow me to communicate over Ethernet, and I don't need to understand all the aspects of it. There's kind of basically a programming shorthand that lets me access that without having to know all the ins and outs of it. But Josh, did you want to elaborate some more on this?
Well, I just wanted to point out that one of the things that makes the Arduino accessible as a programmable microcontroller is the USB port, because you can hook it up to a computer and it thinks that USB port is a serial device, and you can upload code through that. But if you point out the 6-pin cluster, so that's not a 6-pin cluster.
Oh, this one.
Yeah, that's a traditional method of programming a microcontroller. There's a special device that puts top serial on one end and then plugs into that, and that allows you to upload code. You notice that on the left, there's a second set of 6-pin that allow you to program a second microcontroller. And as it comes, all that microcontroller is designed to do is talk to the main microcontroller as a serial device, and then talk to the USB port to transmit data back and forth to the computer. But I've actually successfully reprogrammed that chip to, for instance, have the Arduino show up as a regular keyboard. So when you plug it into the computer, it thinks it's an HID device, and then you still communicate to that chip through the main microcontroller and use it as a keyboard. I've seen people create alternative keyboards, like for disabled people with really large keys. And so they're making their own hardware, and then they're using that to communicate to the computer.
Very great.
When was the first time you actually talked about this? When did you start working about it? And how did you?
I mean, because I've been working in a world of creating crazy art, I think that and because I'm curious. I mean, it was actually one of my original speeches that I was writing for this. I was like, "Hi, my name's Tom Zeppi, and I have a dis-ease. I'm curious." You know, and it's incurable. It's just, you know, insatiable, you know, ability to pursue and learn. And I don't actually know how I originally found out about it. You know, it might have just been through just, you know, my interactions, but I was fascinated. As soon as I saw it, I have to say, though, there was a buddy of mine at this artist warehouse I used to work at who he programmed, you know, microcontrollers, PIC microcontrollers, and I would work with him on little small electronics things, and he would teach me a lot. And I actually built an electric vehicle. It was like a steampunk motorcycle that he helped me to build, and I couldn't have done it without him, and that was like in 2007 and so forth. So, and I mean, the Arduino is really only like 7 or 8 years old, you know, so it's really relatively new. So it's been, you know, through friends of mine that are doing electronics and through trying to figure things out that I kind of found my way into it. Yeah. No, I don't. I mean, I did actually go to college as a physics major, but nothing to do with electronics. I was actually more interested in like physical sciences and things like that. So. Where would be a place in the city? Well, there's a few. Yeah, actually. Yeah. There's Converge. There's Gray Area Foundation for the Arts. There's some more underground spaces, like where I have my shop right now, which is called the Box Shop, which is out at Bayview Hunters Point. There's the Crucible in West Oakland. Noise Bridge is another great place to go, actually, for especially. There's quite a few like hacker spaces. What was the one that you mentioned? Tech Shop is a great place. Yeah, Tech Shop is great because they have like really great tools. They have 3D printers. They have a water jet cutter. They have they have a wood shop. They've got things like that. Is there another question I saw? Is it similar to EEPROM? Yeah. Yeah, you can. These have flash memory, so you can program them multiple times over, thousands of times.
To answer your question correctly, it's got flash for it's got RAM for doing programming. It also has eScript on there for storage, so that you can power down.
Yeah. So one of the things I learned originally through prepping for this talk was that I started researching a little deeper into microcontrollers, and like the first chips, it's like they either were programmed once or they were you could reprogram them, but they had a quartz crystal that you had to flash with ultraviolet light to erase the memory. Yeah, that's basically what EEPROM is. So that's what we were dealing with. That was just like 20 years ago, so. The cost? Well, you can get an Arduino for $20, $25. The chip itself. So if you wanted to, like for instance, I was showing you here, you could just get the chip. It's like pennies or $1 or something like that, and then you could wire up your own electronics on it, and you could spend a lot less, but spend a little more time. But what's so great about the Arduino is that they've done all that work for you. I mean, it's like $25. It's like, just buy this thing,
You can get the older models really cheap.
Oh yeah, you can definitely, they've been kind of upgrading, but kind of more or less keeping the same form factor to keep it compatible with the existing shields that people have created, which is again a great thing about the open source community.
The Uno is officially their first official release. That's why it's called Uno version 1.
Right.
There's also, because the design of the basic design is always open source, the software is open source, you can get stripped down Arduinos for sort of $10. Like,
Yeah.
the version designed just for mounting on a breadboard, on a prototyping board.
Yeah.
It doesn't have as many community fixes for like $8. And you can write code on big ones and put it on the $8 ones for a bunch of them.
Or for instance, this one just has USB, but now they have an Arduino. It's like a Wi-Fi Arduino, so it has a Wi-Fi chip built into the board. So you buy that, and you can just communicate it with it over Arduino, Wi-Fi out of the box.
Also, that Arduino has a new model out for Leonardo. It's the Uno form factor, but a single chip on the chip itself. So it's got two chips in it.
Right. So yeah, there's like little variations and little improvements, and there's diversity has come out, So it's like you kind of have to kind of navigate the field. Like there's online guides now about which Arduino is right for me, But it's cool that they're there, Yeah. Do I have a blog? I do, but it's not very current. Tom Seppi is my name. TomSeppi.com is my website. You can check out some more of my stuff. Thank you so much. It's been wonderful to share with you tonight.